Alright, what's going on? In this video, we are going to look at the unit circle and graphing. These videos that I'm doing, it'll be, about 4 or 5 lecture videos on graphing trig functions. This first video is we're going to look at the unit circle, and we're going to look at the basic graphs of sine and cosine. The next video in the playlist will be graphing sine and cosine. And then the video after that will be graphs of secant and cosecant. And then the video after that will be graphing tangent and cotangent. Watch all the videos. This is typically how it's split up in a trig book. I'm just going through the sections and doing full lecture videos on these things. So if you go through all the videos, you should have a pretty good grasp on how to graph these things. Now, when we graph the ones in this video right here, it's very important that you get it, because I mean, if you can understand this video, the rest of them are going to be real easy. It's real important to get this. But before we get into the graphing, let's look at the unit circle. Now, here's an image of the unit circle. Personally, I don't like the unit circle. I don't teach the unit circle in my classes. Some teachers like it, some don't. Let me tell you why I don't like it is because the unit circle only works on these special angles: 30, 45, 60, 120, 135, 150, and so on. I mean, you can see the angles that it works on. But what happens when you don't have these angles? What do? Well, you have to use reference angles. And to me, it's more important that you understand how to do reference angles rather than learn this unit circle. Because if you can do reference angles, that works for everything. The unit circle doesn't. But I've got some examples here where we're going to find the exact value. We're going to find the exact value of these trig functions. I've got 4 examples. We're going to use the unit circle, and then I'm going to work those same problems using reference angles, because I think reference angles are way more important. And if you want to see something about reference angles, look at the video in the playlist on reference angles in this playlist here, or search my channel for reference angles and watch those. There's a couple of videos. All right, so let's get started. So if alpha is an angle in standard position whose terminal side intersects the unit circle at point xy, then the sine of alpha is y, cosine alpha is x, tangent alpha is y over x. All right, and then of course what you've learned in the past in trig is cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. And of course, for the cosecant, secant, and cotangent, that's provided the denominator is not 0. All right, so basically all this means is sine alpha is y, okay? It's the y coordinate of the point. So see, like here, 30 degrees, the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. And the tangent of 30 is 1/2 over square root of 3 over 2. Okay? So you can get the values by looking at, just find the angle on here and write the answer down is all you got to do. But as I've talked about in past videos, if you watch my videos, you need to memorize the sine, cosine, and tangent of 0 degrees, 30, 45, 60, 90 degrees, 180 degrees, 270 degrees, and then back to 360. You just need to memorize those. Because if you memorize 30, 45, and 60, the sine, cosine, and tangent of 30, 45, and 60, then you can get the rest of these with reference angles. Okay? And I'm going to show you that, when we do this. Like I said, it's much more important that you learn reference angles rather than unit circle. And if your teacher concentrates on that unit circle more than they do reference angles, go tell them to concentrate on reference angles more. All right, so here, find the exact value of each trigonometric function. So sine 45 degrees. So all I do is I just come here to 45 degrees and I go to the y-coordinate. Well, sine and cosine, they're the same at 45 degrees, but come here to the y-coordinate, you get square root of 2 over 2. And so this answer here is square root of 2 over 2, and that's your answer. Okay, the unit circle, that's easy, okay, but it doesn't work for everything, and you'll see that later on in the trig class. All right, what about cosine of 2 pi over 3? Well, let's come around here. Here's 2 pi over 3. We're looking for cosine, and remember, cosine is the x coordinate, so it's what? Negative 1/2. And so this is equal to negative 1/2. All right, let's look at the next one. Tangent of pi over 2. Tangent of pi over 2. There's pi over 2. All right, what's tangent? It's y over x. So y over x, 1 over 0. So this is equal to 1 over 0, which that is undefined. Okay. Now what about this? Secant of pi over 3. Secant of pi over 3. Well, what is secant? Secant is 1 over x. All right. So let's see, we got what was it? Yeah, pi over 3. So we come here to pi over 3, and remember, it's the x value, right? So the x value is 1/2, and so secant is 1 over 1/2. And so this is 1 divided by 1/2, or 1 times the reciprocal of 1/2, which that gives us 2. Okay? All right, so that's using the unit circle. It's quick, okay? It's quick, and, it's easy to use. But like I said, it's more important to be able to do reference angles. Now, let's look at the reference angles. So if you've watched the previous video or you're in a trig class, you should know how to do reference angles by now, or you should have been exposed to reference angles by now. So as far as sine 45 degrees, remember what I said. You've got to memorize sine, cosine, and tangent of 30, 45, 60 degrees, as well as the 0, 90, 180, 270, 360. So if you've got sine 45 memorized, well, that's just square root of 2. Square root of 2 over 2. Okay, so there's nothing to do there with reference angles, because those angles there in this first quadrant here, see, this right here, let me get a red one. This right here, this is your first quadrant. You just memorize those angles. Okay. All right, now what about cosine of 2 pi over 3? Let's work that one out. So to use reference angles, we've got 2 pi over 3 here. There's 2 pi over 3. And I'm not going to go into detail explaining reference angles and all that. If you need to see that, go watch the other video. I go into more detail on that. All right. So this is my reference angle. And in previous videos, we used like theta prime to represent the reference angle. So, and remember, the reference angle is always measured off the x-axis. So I know from here all the way around to here is 180 degrees, but we're in radians, so it's pi. So the reference angle is pi. If I take pi and then I subtract off this angle 2 pi over 3, that's going to leave me with just my reference angle. So that is pi over 3. Okay? So now what are we doing? We're doing cosine of 2 pi over 3. All right? Well, let's ask ourselves, what's the cosine of pi over 3? Well, remember pi over 3, that's like 60 degrees. And so the cosine of that is 1/2. So what is the reference angle doing? It's giving you that value, 1/2 in this case, okay? It's giving you the value. Now we've got to go and say, okay, what quadrant are we in? Well, we're in the second quadrant. Is cosine positive or negative in the second quadrant? Cosine's negative, and so it's negative 1/2, just exactly what we got. Okay? All right. And yeah, reference angles, it's a little more work. It's a little more work. But I'm telling you, be able to do reference angles, that's going to help you so much more later on in the course. And if you're going into, if you got to take higher math like calculus and stuff like that, it's going to really benefit you. Okay? All right. Now, this one, tangent pi over 2. Well, that's at 90 degrees, right? That's one of the ones you have to memorize. So you've just got that memorized. Tangent of 90 degrees is undefined. All right. And then we've got secant of pi over 3. Well, secant of pi over 3, that's not one of the ones I told you to memorize, right? I just said you need to memorize those angles I listed in the first quadrant and the 30, 45, and 60, and then 0, 90, 180, 270, and 360. You got to memorize those of sine, cosine, and tangent, right? I didn't say anything about secant, cosecant, and cotangent, did I? All right, so you've just got to memorize for sine, cosine, and tangent. Well, what do we know about secant? We know secant is the reciprocal of cosine. So if I can find the cosine of pi over 3, okay, pi over 3 is in the first quadrant. So that is the reference angle. All right. Like I said, if me going over these reference angles right now, I'm not going into a lot of detail. If this is kind of confusing for you, you need to go back and watch that video. Okay, just search my channel for reference angles. Or if you're in this playlist, I think it's the video right before this one. All right, so what's the cosine of pi over 3? Well, that's the same thing as the cosine of 60, right? So the cosine of pi over 3 is 1/2. But what are we looking for? We're looking for secant. And so I know secant is what? The reciprocal of cosine. What's the reciprocal of 1/2? 2. And there's your answer. Okay? So yeah, while the unit circle is easy and everything, if you've got it memorized, okay, it's easy and everything, but it doesn't work for everything. All right. All right. So now let's take a look at graphing. So we've got a definition. If y equals f of x is a function and a is a non-zero constant such that f of x equals f of x plus a for every x in the domain of f, then f is called a periodic function. The smallest such positive constant a is the period of the function. All right, so a periodic function, that's a function that it repeats, okay? You graph it over an interval, and then it just keeps repeating over that same interval as you move out. Now we have and the trig functions are periodic functions. So we've got a definition. The amplitude of a sine wave, or the amplitude of the sine function, is the absolute value of half the difference between the maximum and minimum y coordinates. Okay, so that's the definition they give you for amplitude. Pay attention to it, but don't worry about it too much. There's an easier way to do amplitude. Basically, and well, I'm not going to tell you now. Once we get into graphing these things, I'll show you how to find the amplitude real easy. All right. Now, the one thing I want to mention also before we move on, that for the period for sine and cosine is 2 pi. It repeats every 2 pi. So, and I guess I should write that in a little more detail. For y equals sine x and y equals cosine x, the period is 2 pi. Okay, so you graph it. You can graph it from 0 to 2 pi, and then from 2 pi to 4 pi, it repeats. 4 pi to 6 pi, it repeats. Every 2 pi, it repeats. All right? So, to graph these things. So, this right here, this is just the basics, okay? The basic of graphing sine. And we'll do the same thing with cosine in just a minute. This right here is so important because if you get this, then you'll be able to graph anything. Okay? All right. So let's graph this thing over one period. So if I graph this thing, I've got to mark off the 5 important points and the amplitude, the maximum and minimum values. Well, I got to mark off the maximum and minimum values, and then those 5 important points. Okay, and I'm fixing to show you what that is. So y equals sine x, that period is 0 to 2 pi. That's what we're going to graph it over. So we're going from 0 to 2 pi. All right. Now, the amplitude is 1. Okay. The amplitude is equal to 1. What's the amplitude? The amplitude is the number in front of the trig function. That goes for sine and cosine. All right, the amplitude is the number in front of the trig function. In this case, there's not a number there. It's understood to be 1. All right, so my maximum and minimum value is going to be 1 and negative 1. Okay, so that's easy so far. All right, and this is not really have them spaced out evenly. That's a little more even. All right, so as far as the way we started this, mark off 0 to 2 pi. That's for sine x. Maximum and minimum value, mark that off. That's going to be the first thing you do every time. All right. Now, what we have to do now is from 0 to 2 pi, we have to break that up into 4 equal intervals. Okay? So I need the midpoint from 0 to 2 pi. And obviously that's easy. That's pi. All right? Let's come over here to the side. I'm going to show you how you get it worked out. I know you don't need to really show how to work this one out, but I'm going to show you anyway. So to find the midpoint between two values, you just add them up. And that equals 2 pi. And then you half it. Then you do a half times 2 pi, which is pi. And that's how you get the midpoint. All right. Then I need the midpoint between pi and 2 pi. All right. So I can come over here to the side and I can do pi plus 2 pi equals 3 pi. And then I do 1/2 times 3 pi, which is 3 pi over 2. And so this is 3 pi over 2. All right. All I'm doing is breaking this up into 4 equal intervals. This is what you're going to do every single time for every sine and cosine function. Okay. Next, I need the midpoint between 0 and pi. Well, obviously that's just pi over 2. Let's come over here and show how we get it. 0 plus pi over 2 is pi over 2. And, I'm sorry. I don't know where that came from. 0 plus pi is equal to pi. And then, because I'm finding the midpoint between 0 and pi. And then 1/2 times pi is just pi over 2. And there you go. All right. That right there, that's the most difficult part about graphing these things. Okay, that's the most difficult part. So now, just remember, all you got to do now is remember the basic graph of sine, which is this. So remember, sine starts out at 0, then it goes to its maximum value, then it goes back to 0, then it goes to its minimum value, and then it goes back to 0. That's sine every time. Okay? Whatever period you're graphing this over, okay, you start out at 0, maximum, 0, minimum, 0. And then you just draw in your graph. And there it is. It's that simple. Now what's going to change, these values here are going to change. Your maximum and minimum may change. But once you get these points here, these 1, 2, 3, 4, 5 points, that's the graph of sine every time. Okay? All right, let's look at another one. All right, so here I want to graph y equals 2 sine x. All right, same thing. I'm going to graph it from 0 to 2 pi. If I can draw that a little straighter. All right, so what's my amplitude? Well, the amplitude, that's the number in front of the trig function. So it's 2. So my maximum and minimum value is going to be 2 and negative 2. Okay? Just like the last problem. And I'm graphing it over the period 0 to 2 pi. And then I want to break this up into 4 equal intervals. I'm from 0 to 2 pi. Look, it's going to be the same thing as this. I would just have to do this. I'm not going to show the work. We showed it in the first problem, so I'm just going to write them down. So this will be pi, 3 pi over 2, and pi over 2. Now, to graph sine, it starts out at 0. It goes to its maximum, 0, back to its minimum, and then back to 0. And so then I can draw the function, and there's your graph. Okay. Now we're gonna do some more in this section. Okay, we're gonna do some more in this section that are a little more difficult, where this thing's gonna shift right or left, and we'll do one where it shifts right or left and up and down. Okay, but in the next video we'll do some problems that are more difficult than this with sine and cosine. So be sure to watch the next video also. All right, so let's look at cosine. So remember, I told you the period for sine and cosine is 2 pi. Okay, guess what? We're graphing cosine the exact same way that we graph sine. It's the same thing. Okay, and if you can learn the way I'm showing you this, you're not going to have any problems with secant, cosecant, tangent, or cotangent. Okay, I promise. All right, so let's graph this thing. All right, so I need what's the amplitude? The amplitude is 1. That's the number in front of cosine. So my maximum and minimum value is 1 and negative 1. And I'm graphing from 0 to 2 pi. And then I want to do what? I want to break this up into 4 equal intervals. Okay, see, we're doing the same thing that we did with sine, with the sine function. We're doing the exact same thing. Okay, so I split this up. We did that in the first problem. So that's just, I'm just going to write it down, pi, 3 pi over 2, and pi over 2. All right. Now, see, nothing's different, is it? Now we draw the cosine function. So remember, with sine, what did it do? 0, max, 0, min, 0. Well, cosine, so you've got to remember this. So just remember what we did here. This is important, okay? 0, max, 0, min, 0. That's important to know that. That'll go for all the sine functions. Now, for cosine, this right here, how we're going to graph it, the shape of cosine, this is important. Cosine starts out at its maximum, then it goes to 0, then it goes to its minimum, 0, and then back to its maximum. And so cosine is going to look like this. And there's your graph of cosine. All right. You see how easy that is? It's easy to do. Like I said, the most difficult thing is getting your points. Those important points there. All right, so let's look at this one. This one's a little different. This is graph y equals negative 3 cosine x. All right, well, let's do the same thing. Like I said, nothing's different. All right. So now the amplitude is what? The number in front of cosine, which I need to go on and say a little more about amplitude. The amplitude is equal to the absolute value of that number. The amplitude's 3. So my maximum and minimum value is 3 and negative 3. All right. And I've got theorem and definition written here about amplitude once we get done with this problem. All right. So now I'm graphing from 0 to 2 pi, 0 to 2 pi. All right, look at that. See, everything's the same. 0 to 2 pi. Break it up. That's going to be pi, 3 pi over 2, and pi over 2. All right, so there you go. Now, let's look at this. Cosine starts out at what? Its maximum, right? It starts out at its maximum up here at 3. But wait a minute, there's a negative in front. Okay? So what does that negative do? Well, cosine starts out at its maximum, but because there's a negative, that's going to flip it down to its minimum, right? Because look, if that negative wasn't there, we would start up here at 3. It would start out at its maximum, all right? But since there's a negative, that means we start out at the minimum, okay? And I'll just show you real quick. Look at this. Y equals negative 3 cosine of 0. See, if we take 0 and plug it in for x, that's negative 3 times, what's the cosine of 0? Well, that's one of the ones you're supposed to remember. You can go back and look at your unit circle if you want to, but you need to have that memorized. That is 1. Cosine of 0 is 1, and that's negative 3. Okay, and then cosine goes to 0. So what does cosine do? Maximum, 0. Then it goes to its minimum. But since we have a negative in front, that's going to flip it up to its maximum. And then we go to 0. And then what does cosine do? Max, 0, min, 0, max. It ends with its max. But because we have the negative in front, that's going to flip it down to its minimum. And so this graph is going to look like this. See that? And look, let's just go back up here to this sine function. Okay? What if I had a negative in front of the sine? Okay, let's look at that. What if that was negative sine x? Okay, what if that was the case? Negative sine x. Well, sine starts out at 0, then it goes to its maximum. But since I have a negative, that's going to flip it to its minimum, right? So sine goes 0, max, 0, and then it goes minimum, right? But because I have a negative in front, that's going to flip it up to its maximum and then back to 0. And so the sine function would look something like that. All right? So that's if there was a negative in front of the sine. I just wanted to show you that. But yeah, but look, the main thing is getting these points here. That's the important thing. The 5 points along the x-axis and your max and min value. All right. So here we go. The amplitude of y equals a sine x or y equals a cosine x is the absolute value of that number. Okay, absolute value of a. It's the absolute value of the number in front of the trig function. All right, so now let's look at phase shift. So the phase shift of the graph y equals a sine of bx plus c or y equals a cosine of bx plus c is negative c over b. So the phase shift, that tells us how much we move the graph left and right. Okay? So, I mean, yeah, all it is it's just negative c over b. Whatever c is, it's negative c, and then b. So the c, that would have the opposite sign of what you see here, and then you would put b underneath, and that tells you how much it moves left and right. All right, so now let's look at this. So graph y equals sine of x plus pi over 6. And, you know, actually what I want to do here, let me see. Yeah, what I want to do here, I want to actually change this plus here. I want to change it to a minus. And then what we'll do, we'll come down here and change this one to a plus. Okay. All right, so let's look at this. So graph y equals sine of x minus pi over 6. Determine the phase shift, amplitude, and the range of the function. All right. Now, remember what I told you. The period for sine x and cosine x, okay, is 2 pi. All right. And we graph it from what? From 0 to 2 pi. That's what we've been doing the whole time. 0 to 2 pi. All right. And that was for sine x, and that was for cosine x. But do you see the difference? I've just got an x there. Here I have an x minus pi over 6. Okay. So that's telling me I'm not going to be graphing it from 0 to 2 pi. This thing's shifting. Okay. So how do we determine what we graph it over? How do we determine that? Well, this is the way I like to do it. I think this is the easiest way to do it. So this right here, we're taking the sine of x minus pi over 6. We're taking the sine of x minus pi over 6. So I like to take the x minus pi over 6. Now the period for sine x is between 0 and 2 pi. So I'm going to put this thing between 0 and 2 pi. I'm going to write out this compound inequality here. And you should know how to solve these from algebra. So if I add pi over 6 to all three parts, I get pi over 6 less than or equal to x less than or equal to, let's see, what is that? That's going to be what? 13 pi over 6, 2 pi plus pi over 6. Let me just, I'm pretty sure that's right, but I'm going to double check, because if I don't and I miss it, I will hear it in the comments. Yeah, 13 pi over 6. All right. So now let's graph this thing. So what this is telling me is, well, first, what's the amplitude? That's the number in front of the trig function, 1. So I know my maximum and minimum value is 1 and negative 1. Okay? Now, what I'm doing by doing this here, solving this inequality here, this right here, this x between pi over 6 and 13 pi over 6, that tells me what interval I'm graphing it over. So I'm graphing it from pi over 6 to 13 pi over 6. So basically what it does is it takes that from 0 to 2 pi, and it's shifting it to the right pi over 6 units. Okay? Now, so by solving this inequality and getting this, that gives me the beginning and end of the interval, the endpoints. Okay? Now guess what? I do the same thing that I've been doing on all those other problems. I'm going to bust this up into 4 equal intervals, just like I did before. Okay? Well, this is not from 0 to 2 pi anymore. So let's come over to the side and show our work how we get the midpoints. So the first midpoint, I need the midpoint between pi over 6 and 13 pi over 6. So I'm going to come over here. I've got pi over 6 plus 13 pi over 6. And that's 14 pi over 6. Let's see, 14 over 6, that's what, 7 pi over 3. Yeah, so that's going to be 7 pi over 3. Now, what do? I add them up and then I half it. So now I got to take half times 7 pi over 3, which that is going to give me 7 pi over 6. And so this is 7 pi over 6. Right? Hope everybody's good with that. Now, let's find the midpoint between 7 pi over 6 and 13 pi over 6. So I've got 7 pi over 6 plus 13 pi over 6. That is 20 pi over 6. And then if I reduce that, let's see, 2 goes into both of them. That's going to be 10 pi over 3, right? Yep. And then I've got to half that. So a half times 10 pi over 3, well, that's what? 5 pi over 3. So this is going to be 5 pi over 3. Now we need the midpoint between pi over 6 and 7 pi over 6. So let's do that. So I've got pi over 6 plus 7 pi over 6. That is 8 pi over 6. And that reduces to 4 pi over 3. And so then I have to half 4 pi over 3. And so that's going to give me 2 pi over 3. So this is 2 pi over 3. All right. So, you know, a little more to do. Having to split that up into 4 equal intervals. But I'm telling you, if you understand how to get these numbers here that I've just gotten, you can graph all the trig functions because they're all going to be done the same way. All right? It's the same process. So let's see, what are we graphing? We're graphing the sine function. So sine, what does it do? It starts out at 0. And see, I'm not starting over here at where x is. I'm not starting over here where x is 0. I got to start at the first, at the pi over 6. Okay? And so for the pi over 6 sine, it starts at 0, then it goes to its maximum, 0, then it goes to its minimum, and then back to 0. And so this would be our sine function. That's the graph. All right, so I know all of these that I'm graphing so far, I'm graphing them over one period. I tell you what we'll do is we'll look at this one after we get done with the next problem, and we'll graph it over 2 periods so you can see what it looks like. All right, now what about this one? Oh, I'm sorry. Look. Determine the phase shift, amplitude, and the range of the function. All right, so let's look at this. Let's just write the amplitude. That's equal to 1. We already got that. The phase shift is what? Minus c over b. Well, what's c? Well, c is negative pi over 2. I'm sorry, negative pi over 6. So the phase shift is equal to negative c, which is negative pi over 6 over b. Well, remember, see, there's your c, and b is the number in front of x. So what's the number in front of x? That's 1. So that's over 1. So the phase shift is pi over 6. Now, let me show you something else that's pretty cool here. You know, you can remember this negative c over b, and look, by all means, that's good to memorize that. You need to know that. Okay, you need to know it. But look, if you're graphing this thing and they ask you for the phase shift, you see this inequality that we solved? There's your phase shift right there, that number on the left. Okay, there's your phase shift. All right, now they wanted to know the range. So what's the range of this function? Well, the range, that's the y values that it's hitting, right? So what all y values is this function going to hit? Well, we can see the smallest y value is going to be negative 1, and the largest is going to be 1. So the range is negative 1 to 1. There's your range. And the negative 1 and 1 is included because sine can equal negative 1 and it can equal 1. All right, let's do this. All right, so here we got a graph y equals cosine of x plus pi over 4 plus 2. All right, guess what? Same thing. Same thing. You see that x plus 4 in parentheses? We're going to do the same thing there that we just did. 0 less than or equal to x plus pi over 4 less than or equal to 2 pi. And then I'm going to subtract pi over 4 to all 3 parts. And so that's going to give me negative pi over 4 less than or equal to x less than or equal to, what is that going to be, 7 pi over 4? All right. So that's what I'm going to do this graph over. I'm going to graph it from negative pi over 4 to 7 pi over 4. That's the period, or the interval that I'm going to graph it over. Now, you might be thinking to yourself, well, what about that plus 2 there? I forget about it for now. Okay, don't worry about it right now. Pretend like it's not even there. And we'll worry about it when we go to put our points on the graph. And you'll see what I'm talking about. So for right now, just forget about this plus 2 out there. What that's going to do, what the number out here does, it shifts it up or down. Okay. All right, so let's come over here. Whoop. Well, let me do this. So I'm going from negative pi over 4 to 7 pi over 4. All right. And then, you know, like we did in these previous problems, we mark our max and min values. Well, we know our max and min values in this problem is 1 and negative 1 because that's our amplitude. Okay, that's the number in front of cosine. But notice I didn't put the y in the y-axis in there yet. See, I didn't draw the y-axis in there. And why not? Well, let's look at this. Notice on this problem here, the interval that I'm graphing it over, it's the entire interval is on the right-hand side of the y-axis. In this problem, some of it's on the left, some of the intervals on the left-hand side of the y-axis, and some is on the right-hand side. So if I draw this y-axis in here, is that where it goes? Does it go there? Or does it come in here closer? Or is it further away? Where does it go? Well, I don't know. Let's split it up first and then draw in, and then we can get a better idea where the y-axis needs to be. You see what I'm talking about? All right, so let's see here. So we're going to find the midpoint between negative pi over 4 and 7 pi over 4. So I've got negative pi over 4 plus 7 pi over 4. Well, that's going to be what? 6 pi over 4, which is 3 pi over 2. And then if I half that, 3 pi over 2 times 1/2, that is 3 pi over 4. And so this is 3 pi over 4. And then I need the midpoint here. That's going to be, let's see, 3 pi over 4 plus 7 pi over 4. And that is 10 pi over 4, which is 5 pi over 2. And then if I half the 5 pi over 2, that's going to give me 5 pi over 4. Okay. See, I'm doing the same thing that I've been doing the whole video on graphing these things. And now I need the midpoint of negative pi over 4 and 3 pi over 4. So I'm going to add them up. That's 2 pi over 4, right? That's 2 pi over 4, which is just pi over 2. And then if I half that, that's going to give me pi over 4. And so this is pi over 4. All right, so now for our y-axis, we can see where the y-axis goes now. It's exactly between negative pi over 4 and pi over 4. So it's right in the middle of those two. And that's one thing I would recommend you doing. If your interval is going from a negative number to a positive number, then do these points first and then draw your y-axis in there. But if it's going from a positive number to a positive number, I mean, you can go ahead and put the y-axis in there because you know everything's on the right-hand side of it. Same thing, if both of these numbers are negative, you can go ahead and draw your y-axis in there, and you know your interval is going to be on the left-hand side. Okay. All right, so we know my max and min value is going to be 1 and negative 1. Well, I'm sorry. Let me redraw that. I got all excited and forgot about that plus 2 there. So what we've been doing so far when we've been marking these max and min values, we've just been putting this 1 point here, right? We've just been putting the minimum and then the maximum, and that's it. But this thing's going to shift up or down. So let me go ahead. I want to just go ahead and rewrite the problem here. Y equals cosine of x plus pi over 4 plus 2. All right. So let's go ahead and put in some more marks. 1, 2, 3, 4. 1, 2, 3, 4. We got 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. All right. So far, nothing's really different, right? Nothing's that different. Now, still, I want you to forget about that positive 2. Just forget about it for now. Okay? So let's look at cosine. Just think about cosine. Where does cosine start? It starts at its maximum. Okay, keep in mind, I'm not considering the plus 2 right now. All I'm looking at is this right now. So if I were graphing just this, that would start out at its maximum, which is what? 1. See that? So I'm starting out here at 1. Now look at the plus 2. I'm starting out at 1. There's a plus 2. So what is that going to do? It's going to move it up 2 units. You see that? And then where does cosine go? It goes from its maximum to 0. See, it's starting here at negative pi over 4. And then the next important point is what? Pi over 4. So cosine goes to 0. But what do I have? I have a plus 2, so that's going to knock it up 2 units. And then cosine, okay, so maximum, 0, and then it goes to its minimum of what? Negative 1. But then that plus 2 is going to bump it up 2 units to that positive 1. And I know this graph is going to look crappy, but it is what it is. And then we go, and then cosine goes back to 0, but that's going to knock it up 2 units. And then cosine goes back to its maximum, which is 1, but that plus 2 is going to bump it up 2 units. And so our cosine is going to look like, and no, it's not going to look that flat. Okay, it's probably not going to look that flat, but you get the idea of what to do. Okay, so even though this plus 2 was out here, all we did is just look at this one. Okay, we looked at this one and said, okay, we go to max, 0, min, 0, max. Which in this case, since the amplitude was 1, our max and min is positive 1, negative 1. Okay, so that's what we did. We went to 1, 0, negative 1, 0, 1. And then we said, okay, but the 2, that's going to bump each one of those up 2 units. So that's where the 3, the 2, the 1, the 2, and the 3 come in. I hope that made sense. Okay. All right. So now let's go back to this problem, and oh, I'm sorry. And they still want us to find the phase shift and range of the function. Okay, so let's do that. So the phase shift, we'll go ahead and find it the minus c over b. So negative c, so that's negative pi over 4 over b, which is 1. See, there's c, positive pi over 4, b is 1. And so that's negative pi over 4. And so there's your phase shift. But like I said, if you're graphing it and you solve this inequality, there's your phase shift right there. And then the range, well, what's the smallest and largest y value? Well, the smallest y value is what? 1, and the largest is 3. So the range is 1 to 3. And then they didn't ask us to find the amplitude, but we know the amplitude is equal to 1. We know that. All right. So now let's come back over here to this one. Remember, I promised you we would graph it over more than one period. So the main thing to do here is graph it over 2 periods. So first, graph it over the 1 period. And there's a couple of ways you can do this. You can extend the line on out. And what I can do is, let's see if I can get about the same distance here. And then I need this, and this point, right? So you can see here's the first period. I just graphed it over that interval. And then the second period is going to be from here to here. And see, it's the same thing. 1, 2, 3, 4 equal intervals. Everything's just shifting over. All right. So what's the period? What's the period of the sine function? It's 2 pi, right? Same thing with cosine. period of cosine is 2 pi. So I can actually, to get this point here, I can take the 13 pi over 6 and add 2 pi. So that's going to be what? That's going to be 12 pi over 6. So that's 25 pi over 6. So this would be 25 pi over 6. Okay, because see, the distance from pi over 6 to 13 pi over 6 is 2 pi. If you do 13 pi over 6 minus pi over 6, you get 2 pi. That's the distance between them. Okay, and then, I mean, you can go back and you can do the same thing. You can add these up and then half it. Okay, I mean, you can do it like that, or what you could do, you could add 2 pi to each one of these values to get these. So if I add 2 pi to that, that's going to be, let's see, let's do this, 2 pi over 3 plus 2 pi. That's going to be 6 pi. That's 8 pi over 3, so that should be 8 pi over 3. And then if I add 2 pi to this one, 7 pi over 6 plus 2 pi, that's going to be, let's see, what is that, 19 pi over 6. I'll have to check myself, but, and then if I get 5 pi over 3 plus 2 pi, see, all these points are just moving 2 pi over. See, I just added 2 pi to this to get this. So to get this one, I would add 2 pi to that one, and so on. So that's going to be what is that, 11 pi? 11 pi over 3. 11 pi over 3. And look, you can do this. Let's do like we did up here. So let's take the 13 pi over 6 and 25 pi over 6 and find that midpoint there. So if I take 13 pi over 6 plus 25 pi over 6, that is going to be what? 38 pi over 6. And that reduces to what? 19 pi over 3. And then we have to half it. 19 pi over 3 times a half, which is 19 pi over 6. And see, there it is right there. All right. So now, and you can do that. You can go and get the midpoints of each, or you can just add 2 pi to each of those. Same thing if we went back this way. If we decided to go back this way, you would take the pi over 6, you would do pi over 6 minus 2 pi, and that would give you the furthest point here. And then you would just subtract 2 pi to each one. Okay, or you get this point here, do pi over 6 minus 2 pi, and then you can do the midpoints like I did here, like I did on this one right here. Okay, same thing. All right, so now we're graphing this. We're graphing it over 2 periods. So we've got another period. Okay, so we're going to do it the same way. So here's the beginning of this new period, and we're doing sine. Sine does what? Starts out at 0, then it goes to its maximum, 0, and then it goes back to its minimum, and then back to 0. And so if we continue this on, there it is. And this graph would just keep going like this forever. If you wanted to do another period, add 2 pi to this number right here. That's going to give you the far point, and then just break it up again. All right. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. See you later.